Hello, everyone. Let's study together today. Recovery and purification of high concentration sulfur dioxide tail gas, and low concentration sulfur dioxide. Overview of flue gas desulfurization technology, and widely used among them. Limestone/lime wet flue gas desulfurization technology. Recovery and evolution of high concentration sulfur dioxide tail gas. In the exhaust gas of smelters, sulfuric acid plants and paper mills, the concentration of sulfur dioxide is usually 2% to 40%. The specific concentration depends on the process method adopted. The smelting concentration of metal ore depends on the use of what kind of smelting process and the gap period of operation are determined. Due to the high concentration of sulfur dioxide, the tail gas is recovered and treated. The most economical method is to use sulfur dioxide to produce sulfuric acid. The reaction is sulfur dioxide and oxygen. Formation of sulfur trioxide with vanadium as catalyst. Sulfur trioxide reacts with water to form sulfuric acid. Kennecott, the largest in the United States, in Salt Lake City, copper smelter as an example. For every copper produced by the factory, 32 times 10 to the fourth ton. If the tail gas of sulfur dioxide is not carried out treatment, its emissions will be amazing. From chalcopyrite, the high-temperature smelting reaction formula for producing copper can be known. Copper is generated from chalcopyrite and 5/2 oxygen, and iron oxide and sulfur dioxide. Visible. Every mole of copper produced will be simultaneously to produce 2 moles of sulfur dioxide. In this way, every year will produce about 65 times 10 to the fourth ton of sulfur dioxide. If sulfur dioxide tail gas is not treated, direct emission, its emissions directly account for the United States 3.2% of the total annual sulfur dioxide emissions. If all the sulfur dioxide is recovered, used in the production of sulfuric acid, it can produce 99.5 times 10 quadratic tons of sulfuric acid. Then, it can account for about 2% of the total sulfuric acid production in the United States. The actual situation is that more than 99.9% of sulfur dioxide in this plant is replenished. Used in sulfuric acid production, less than 1% of sulfur dioxide directly. Discharge into the atmosphere. Oxidation of sulfur dioxide to sulfur trioxide. It is an equilibrium reaction, and sulfur dioxide will not be completely converted. The reaction is an exothermic reaction. The equilibrium conversion rate of sulfur dioxide is high at low temperature. However, the equilibrium conversion rate is low at high temperature. Therefore, in order to achieve a higher conversion rate, 3 to 4 stage catalyst beds are usually used in industry, and multi-stage cooling method is adopted to improve the conversion rate of sulfur dioxide. The temperature conversion rate of multi-layer catalytic reaction is shown in the figure. After preheating, exhaust gas with a temperature of 420 degrees enters first catalyst bed. The reaction then enters. The gas temperature in the bed rises. The gas leaves in the first 3 stages. Each bed enters the next section. Cooling needs to be carried out every period of time. The beds in the first 3 sections are usually thinner. To control shorter dwell times, ensure that the reaction deviates from the equilibrium line. To increase the driving force of reaction, it can be seen from the figure. The equilibrium conversion rate decreases significantly with the increase of temperature. Leave the last paragraph. The gas temperature of catalytic bed is 425 C. The conversion rate is close to the equilibrium value at this temperature. By this process, 98% sulfur dioxide can be converted into sulfuric acid. In a simple acid-making process, the remaining 2% sulfur dioxide is directly emptied. With the strictness of environmental protection laws and regulations, the secondary acid production process has been developed, thereby further reducing the emission of sulfur dioxide. The principle is that the lower sulfur dioxide discharged through the first stage process, then it passes through a catalyst bed. The water produced by continuously converting sulfur dioxide into sulfur trioxide carry out absorption to produce sulfuric acid. The two-stage process can usually make 99.7% conversion of sulfur dioxide to sulfuric acid. From the point of view of acid production, due to the gas with high concentration of sulfur dioxide, very cheap, cost of second stage catalytic conversion and absorption step, polymerization, not enough to be compensated by extra sulfuric acid. This is entirely to meet the requirements of pollution control. As shown in the figure, the process of single-stage absorption and flow chart of secondary absorption process. It can be seen from the figure, compared with general absorption. Absorption tower in acid-making process. Separation and circulation device of absorption liquid is not needed. This is due to sulfuric acid produced by dissolving sulfur dioxide in water. Solution is a marketable product. Therefore, there is no need to recover and recycle the absorption liquid. At 20 degrees Celsius, the Heng force coefficient of sulfur dioxide in water is about 10 to the minus 20th power Pascal. Therefore, the absorption process is very fast and effective. So that in the absorption process, it is easy to form fine sulfuric acid mist. After purification, sulfuric acid mist must be removed when gas is discharged into the atmosphere. Next, let's learn together. Overview of flue gas desulfurization methods. Flue gas from coal and oil combustion usually contains low concentrations of sulfur dioxide, according to the sulfur content of fuel. So the fuel, sulfur dioxide directly discharged into flue gas by facilities. The concentration is the order of magnitude of the negative power of 10. For example, under the condition of 15% remaining air, coal with flue gas flow of 1% to 4%. Sulfur dioxide in flue gas only accounts for 0.11% to 0.35%. Fuel oils with sulfur content of 2% to 5% are used in fuels. Then, sulfur dioxide in smoke only accounts for 0.12% to 0.31%. Due to the low concentration of sulfur dioxide, large flue gas flow. Flue gas desulfurization is usually very expensive. Flue gas desulfurization can be divided into two types: abandonment method and regeneration method. Discard method, that is, solids formed in the desulfurization process. The product is discarded. This requires the continuous addition of fresh chemical absorbents. Regeneration method. As the name implies, it is an absorbent after reacting with sulfur dioxide. It can continuously enter a closed-loop system for regeneration. Then, the regenerated desulfurizer and fresh absorbent that needs to be replenished due to loss, then return to the desulfurization system for recycling. Discard desulfurization system is often used at the same time. The dust removal system can effectively capture fly ash and have enough capacity. Regenerative desulfurization system usually needs, before desulfurization, equipped with high and low dust removal system, because the existence of ash flying affects the operation of the recovery process. Flue gas desulfurization can also be according to desulfurizer with solution. Desulfurization in slurry state can be divided into wet desulfurization and dry desulfurization. Wet system refers to the use of alkaline absorption liquid or solution containing catalyst particles, absorb sulfur dioxide from flue gas. Dry method refers to the use of solid absorbent, and the catalyst does not lower the flue gas temperature, and without increasing humidity. Removal of sulfur dioxide from flue gas. Spray drying process used. Desulfurization by atomized desulfurizer slurry. But in the process of desulfurization, evaporation drying of spray droplets, the final desulfurization product is dry. Therefore, it is often called wet, dry or semi-dry method. The following table shows daily development and application. Brief introduction of main flue gas desulfurization technologies. in the table. The flue gas desulfurization process is divided into 4 categories: wet recovery system and dry discard system. Dry recovery system, because sulfur dioxide is an acidic gas, used in almost all washing processes. Aqueous solution or slurry of alkaline substances, most of which are discarded in the process. Sulfur removed from flue gas, and discarded in the form of calcium salt. Therefore, the consumption of alkaline substances is large. In the recovery process, the recovered product is usually elemental sulfur, sulfuric acid or liquid sulfur dioxide. Main wet flue gas desulfurization processes use limestone/lime or sodium carbonate, etc. slurry as detergent. The flue gas is washed in the absorption tower, thereby removing sulfur dioxide in flue gas. The advantages of wet flue gas desulfurization are as follows. First, the desulfurization efficiency is high. In some devices, when the calcium-sulfur ratio is about equal to 1, the desulfurization efficiency reaches 90%. Second, the utilization rate of absorbent is high. It can exceed 90%. Third, the coal type has strong adaptability. Byproducts are easy to recycle. Fourth, the equipment operation rate is high, has reached more than 90%. Disadvantages. However, the investment in the infrastructure construction of this process unit is large, about 11% to 18% of the investment in power plants. Second, the operating cost is high. It accounts for about 8% to 18% of the total operating cost of the power plant. Traditional limestone/lime wet flue gas desulfurization process. As shown in the figure, boiler flue gas is sent to absorption tower after dust removal and cooling. The prepared limestone/lime slurry is used in the absorption tower. Washing flue gas containing sulfur dioxide. Discharge after defogging and reheating. Then, the absorption liquid discharged from the absorption tower flows into the circulation tank. Add fresh limestone or lime slurry for regeneration. Core device of absorption tower flue gas desulfurization system. Large liquid holdup and high relative velocity between gas and liquid phases are required. The contact surface between gas and liquid is large. Features such as less internal components and less pressure loss. At present, the commonly used absorption towers are mainly spray tower and packed tower, jet bubble tower and Dalton tower. Spray tower is the main tower shape of wet desulfurization process. In general, the removal rate of sulfur dioxide is high. Scrubbers are often the least reliable to operate. Its principle. The flue gas contains calcium sulfite and calcium sulfate. Limestone/lime slurry washing. Sulfur dioxide reacts with alkaline substances in slurry. Formation of sulfites and sulfates. So, limestone/lime slurry in fresh slurry. Continuously added to the circulation loop of desulfurization liquid. The solids in the slurry are continuously separated from the slurry, side by side to the sedimentation tank. The flue gas coming out of the dust collector is washed in the absorption tower. Removal of sulfur dioxide. The reaction mechanism is lime method. Is sulfur dioxide and calcium oxide and water reacts to form calcium sulfite and water. Then the limestone method is the reaction of sulfur dioxide and calcium carbonate. Formed calcium sulfite and carbon dioxide. You can find from the table that reaction mechanism of limestone-lime desulfurization method. These two mechanisms show that in the corresponding system, the chemical reaction process that must be experienced. The most critical chemical reaction is the formation of calcium ions, because sulfur dioxide passes through this reaction of calcium ion with bisulfite ion, and removed from the solution. This key step is also highlighted. Important differences in limestone/lime system. Calcium ion generation in limestone system, only with the concentration of hydrogen ions and the existence of carbonate ions. Then, the generation of calcium ions in lime system. It is only related to the existence of calcium oxide. Therefore, when the limestone system is running, pH is lower than that of lime system. The main influencing factors are pH, liquid-gas ratio, calcium-sulfur ratio, airflow velocity, solid content of slurry, sulfur dioxide concentration and absorption tower structure. Then, typical operating conditions of limestone lime flue gas desulfurization system, as shown in the figure. Okay, that's all for today. Thank you all.